We're going to go back and talk about checking regression conditions again, but in the context of multiple regression. So remember, the conditions for regression have a mnemonic that will help you remember them. It's LINE. Like linear regression, it's line. And the conditions are linearity, independence, normality, and equality of variance. So we're going to go through some slides. They're basically the same slides that I did before, but I'm going to go a little bit further with them. So the linearity condition means that when you are looking at your scatter plot, so in this case you have your explanatory variable on the x and your response on the y, the model should look linear. And so this one looks like a curved line would actually fit better than a straight line, so this is a violation of the linearity condition. But there's actually another way to check the linearity condition, and this is in a residual versus fitted plot. And this is a type of diagnostic plot for regression conditions. And what it does is it puts the fitted values, the predicted values from the model, on the x-axis and the residuals on the y-axis. So if you were to focus on a particular point from this plot, so say that point right there, it looks like it's around x is equal to 0. Maybe 6.2, something like that. And then where is it on the y-axis? Let's sort of pull over here. It looks like maybe around 13. So if we were to think about that particular point, the observed value on the y-axis is about 13. And then we would need to think about what the predicted value would be. And so for the predicted value, we go straight up from the x-axis until we hit the model line. So in this case, the model line is that blue line, and that would be our predicted value. And then I could pull over here to see about what that predicted value would be. I would guess maybe, I don't know, 18, something like that. And then the residual is the difference between these two things. So it is the observed value of about 13 minus the expected or predicted 18. So it would be a residual of about -5. And we could think about that same point on the residual versus fitted plot. It's going to be about 18 out and about -5 down. So this is looking like about the 18, and then here is the -5. So that's the same point. And so what I say to imagine is if you take your model line, like the blue line in the scatter plot, and you flatten it out, that becomes the picture that you see in the residual versus fitted plot. So let me see if I can actually just show that to you. So if I took this scatter plot and I rotated it so that the blue line was basically flat, I would get this plot here. The scale is a little bit different, so it looks a little bit different, but you can see that point that we were focusing on becomes this point down here. So that's what you should think about when you look at a residual versus fitted plot. Is it's like the scatter plot, but just rotated so that the line is the y=0 line. So if I look at a residual versus fitted plot, I can also tell if linearity is met. So linearity looks like it is not met because there is a clear nonlinear pattern. If the data was all just neatly along this line, that would look linear. This has a clear curve, so it is not linear. Independence is still the thinking condition, so you still can't assess it from plots. And the ways in which independence can be violated the most easily are when the rows are spatial units. So that would be things like states, counties, zip codes, census blocks, countries, all those sorts of things. Or if the rows are time units, so things like years, months, days, hours, seconds, those are going to be violations of the condition. Not a violation would be a random experiment or a random survey. So no plots to help you out with independence. The next condition is normality. And I think I said before that we weren't going to talk about normality in this class, but I had forgotten that chapter 10 goes into it a little bit. So let's talk about it. So again, I have on the left a scatter plot, and I've got my explanatory and my response. And this is not normal. You can sort of see it because there's more data down here and it's more sparse up here, but it's pretty hard to tell if your data is normal from a scatter plot. So the easier way to tell is from a histogram of the residuals. So what you would like to see is a nice normal distribution, a nice symmetric bell-shaped distribution like that. This distribution is not bell-shaped. It is skewed. It has a far right skew because the tail is reaching out toward the right. And so this is a violation of the condition. So this looks like the residuals are not normal. And then the last condition is equality of variance. I've once more shown you a scatter plot. So this has the explanatory variable on the x and the response on the y. And we talked about we would want a nice even band of residuals above and below the line. This is a violation because it's got a fan shape. So that's a violation. But we can also see it in the residual versus fitted plot. So that's what I have here. I've got the residual versus the fitted value. And hopefully you can see that if I took my plot and once again rotated it so that the line was flat, the scatter plot basically turns into the residual versus fitted plot, and I can see that same fan shape here. So I can also see that the condition is violated from the residual versus fitted plot. So let's look at a good example. So here I've got my scatter plot, and then I've got my residual v fitted plot. So from the residual versus fitted plot, I can check linearity, and I want it to not have some kind of curve going on, and it looks nice and flat. So linearity looks like it is met. I can't check independence or normality very easily from this, but I can check equality of variance. And what I want to see is kind of an even band of residuals the whole way along. And in this case, it looks like that condition is met. And then continuing with the good example, again, this is my scatter plot, and this is my histogram of residuals. So the histogram of residuals doesn't help me with linearity or independence, but it does help me with normality. And this looks nice and normal, nice symmetric bell-shaped distribution. So it looks like normality is met, and then equality of variance we can't check from this plot. So we were able to check linearity from the residual versus fitted plot. That was a check. We were able to check normality from this histogram of residuals. That was a check. We were able to check equality of variance from the residual versus fitted plot, and that was a check. The only thing is the independence. I actually don't know. I think I generated this data, so it should be independent, but I didn't give you any context to know if those rows should be independent from one another.